Last week we learned about slope-intercept form. We also learned about how to write equations in slope-intercept form given different information. This week we're going to go into a little bit more depth, talk about parallel and perpendicular lines, and talk about applications. So when we are looking at parallel and perpendicular lines, obviously the first thing we want to know is the definition of each. So we know when lines are parallel, their slopes are equal and they have different y-intercepts. So we all know parallel lines are lines that will go on forever and never touch, which means the distance between them is always the same. So mathematically, we're saying that those slopes, the slope of the first line, is equal to the slope of the second line, because if they didn't have the same slope, then eventually they would cross one another. So parallel lines have the same slope. This will be important to us if we're going to write an equation using parallel lines, because we will already know the slope if we know the slope of one line. For perpendicular lines intersect at a 90-degree angle, and remember that's that little symbol for 90 degrees. And essentially, we know that the slopes of those lines are opposite reciprocals, which means you're going to flip it over and make it the opposite sign. So if the slope of one line was 5, the slope of the other line would be 1 over 5, and then change the sign from positive to negative. So the first type of question that you might get about this is just to verify if lines are perpendicular or parallel or neither. And obviously I could just get my graphing utility out to do that, but let's go ahead and do it mathematically. If I look at my first equation, 6x plus 2y equals 9, if I want to find a slope, which is how we'll determine if these are parallel, perpendicular, or neither, then I'm going to manipulate this equation into slope-intercept form. And we practiced how to do this last week. Remember, we're going to get the y value by itself, and then of course divide by the coefficient in front of y. So I get y equals negative 6 over 2, which is negative 3x, plus, I'm just going to leave that 9 halves. So what I need you to understand here is 9 halves doesn't really matter. I'm looking at the negative 3. So now what I want to do is look at my other equation, negative 3x minus y equals 3, and see if I also get a slope of negative 3. So I'm going to start by adding 3x on each side to get negative y equals 3x plus 3. And then I'm going to divide everything by negative 1 to get y equals negative 3x minus 3. So what this tells me is that these lines are parallel. They're parallel because their slopes are exactly the same, and if you'll notice, negative 3 and positive 9 halves are not the same value. If I did all of that work and found that they were the same y-intercept as well, we couldn't call them parallel because they would really be the exact same line twice. So here's one of those for you to try. Go ahead and verify if these are parallel, perpendicular, or neither, then press play to see how you did. So again, I'm just going to use that same method. I'm going to isolate the y, first by subtracting x from each side, and then by dividing by 3 to give me y equals negative 1/3. Remember, if there's no number in front, it's a 1, and because it was negative, it was a negative 1. Negative 1/3 x, and then minus 15 divided by 3 is 5. My second equation, I have negative 3x plus y equals negative 1. I'm going to add 3x to each side. I get y equals 3x minus 1. So then I'm looking at negative 1/3 and positive 3. And again, these would be perpendicular because if I took negative 1/3 and I did the opposite reciprocal says flip it over, which means 1/3 becomes 3 over 1, or 3, and change the sign from negative to positive. And because, I shouldn't use an equal sign there, because my two slopes are opposite reciprocals, these are perpendicular lines. The other type of question, and this question is much more common, is if we are given a line like 4x plus y equals negative 8, and we're asked to write the equation of a line parallel or perpendicular to that point. So if you'll notice, I have copied the point slope form that we talked about last week, because this is going to help us on our way. That's what I'm going to use once I know the slope. So the first thing I need to do is take my 4x plus y equals negative 8 and determine what is the slope of that line. And again, the fastest way to go about that is to rewrite this into slope-intercept form. And this one happened to be really easy. I just moved the 4x to the opposite side to get negative 4x, which means the slope of my original line is negative 4. Now, how does that help me? Well, this one says the line parallel. So I'm going to use point slope form with m equals negative 4 because parallel lines have the same slope, and the point to negative 3. And then on my second question, because it says perpendicular, I'm going to use the point to negative 3, but I'm going to use the opposite reciprocal of negative 4, which is positive 1 over 4. So essentially that's what I'm going to do. I'm going to do it twice, so let's go ahead and do it the first time for parallel. Keep in mind that this is my x1, y1, so it's y minus my y value of negative 3. Use my parallel slope of negative 4, and then x minus 2. I'm going to ching on the left side because minus negative makes it plus. And on the right side, I'm going to distribute the negative 4 to get negative 4x plus 8. Don't be fooled by those two negatives. And then I'm going to subtract 3 from each side to get negative 4x plus 5. So again, you can use your graphing utility to verify that this equation and this equation are in fact parallel. And then I'm going to do the same thing for the perpendicular line. I'm going to say y minus my y value, negative 3, is equal to my slope. Remember, this is that perpendicular slope, so I took the original slope, I flipped it upside down and changed the sign. So it's positive 1/4, and then x minus my x value. Same as before, the left side is y plus 3. On the right side, I'm going to distribute. I get minus 2 times 1/4 or 2/4, which I'm going to write as 1/2. You could also turn that into a decimal because it's a nice decimal. Then I'm going to subtract 3 from each side, so y equals 1/4 x, and I'm just going to write minus 3.5, or you could write minus 7/2. And that is my perpendicular equation. Again, feel free on your own to verify that with a graphing calculator. So here's a question for you to try on your own. Go ahead and give it a try, and when you're done, press play to see how you did. The first thing I would do is take a look at the existing equation and find the slope, because as you'll notice, we're trying to do one parallel, one perpendicular to the same line. So I would start by subtracting 2x from each side. That gives me negative 2x plus 4. And then I would divide everything by negative 1 to get positive 2x minus 4. Now again, I don't care about the minus 4, I only care about the 2. So for my parallel line, I'm using a slope of 2 that is equal to the slope of the existing line. For my perpendicular slope, I'm going to use the opposite reciprocal, so I'm going to flip 2 over, and I'm going to change the sign. Now I'm going to use my point slope form to work this out. So y minus my y value, negative 1, equals my slope of 2, x minus my x value of negative 4. Keep in mind, I always like to ching or keep flip change. That gives me y plus 1 equals, distributing gives me 2x plus 8. Subtracting 1 everywhere gives me 2x plus 7. For my second equation, I have the same format using negative 1/2 instead. So y minus negative 4, or again, if you want to just go ahead, y minus negative 1 I got ahead of myself. And if you want to go ahead and write that as y plus 1, that's okay. And then I'm using my slope of -1/2, and then x minus -4. So again, if you want to write that as plus 4, notice it's the same thing I did up here. That gives me y plus 1, distributing the -1/2, -1/2 x. -1/2 of 4 is -2, so I'm going to write -2. Subtract 1 from each side. -2 minus 1 is -3, and so that is the line that is perpendicular. Keep in mind you can always go onto Desmos.com, graph the original line just as it is, graph your two solutions, and make sure that they are in fact both parallel and perpendicular.